In this video, we will talk about some postulates and theorems that are important in finding arc measures. The first one is called the arc addition postulate. The measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. Let's use this figure to illustrate that. In this circle, arc ABC is a major arc and it is composed of two smaller minor arcs that are adjacent to each other. They are adjacent because they share a common endpoint, which is point B. So to get the measure of the entire major arc ABC, we add the red one and the blue one. So that means measure of arc ABC is equal to the sum of measure of arc AB plus measure of arc BC. In this example, a recent survey asked teenagers whether they would rather meet a famous musician, athlete, actor, inventor, or other person. And the results are shown by this pie chart. So if you want to find the measure of arc AC, which is the combination of this pink portion and the blue one, what we're going to do is add 29 plus 108 and we will get 137 degrees. Next, for letter B, we want to find measure of ACD. This is point A. You go in a clockwise direction, that's your point C, and then you stop at point D. So in other words, it's the combination of 1, 2, 3 slices. Since we already know from letter A that the combination of these two is 137, we could just add the remaining portion, which is 83, and we will get our answer, which is 220 degrees. The third one is the measure of arc ADC. ADC is from here and goes in a counterclockwise direction. That's your point B, and that's point C. Since in letter A, we know that the combination of these two is 137, what we can do is subtract that amount from the total of all angles in a circle, which is 360. So we would get 223 degrees. That is not the only way to do it. You can also find the answer by adding 79 plus 61 plus 83 degrees, and you would get the same answer. For the last one, measure of arc EBD, it's a combination of all these slices from E going in a clockwise direction, that's your point B, and then all the way to point B. So in other words, only this portion labeled others, or 61 degrees, is not included. So since we already know that the sum of all angles in a circle is 360, we can subtract this amount from 360 and we will get 299. Another alternative solution is you add every single slice except 61. So 79 plus 29 plus 108 plus 83 will also be equal to 299 degrees. Here are other theorems that are useful in finding arc measures. The first one is congruent circles theorem. Two circles are congruent if and only if they have the same radius. So in this picture, the radius AC has the same number of tick marks as radius BD. So if the two radii are congruent to each other, then the two circles they belong to are also congruent. Let's look at another one. The second example is called the congruent central angles theorem. In the same circle, which is circle A, two minor arcs are congruent. So the minor arcs are CD and DE, if and only if the corresponding central angles, which are CAB and DAE, are congruent to each other. So in other words, if these two minor arcs are congruent, then so are their corresponding central angles. And the converse is also true. If these two central angles are congruent to each other, then their corresponding minor arcs are also congruent. How do you prove that this is true? To prove this, you need to draw additional line segments from C to B and from D to E, so you can form two congruent triangles. You can use your SAS postulates or SSS postulates from the first semester lessons that we had before in order to prove that those two triangles are congruent. And lastly, the similar circles theorem. All circles are similar. By similarity, if you still remember the definition from the previous semester, two figures are similar if and only if the corresponding sides or dimensions form a common ratio or a proportion. So how will you prove that all circles are similar? To prove that all circles are similar, you get the ratio of any two corresponding radii. So the scale factor, or the ratio of proportionality, will just be equal to the ratio of the radius of one circle and the radius of the other. Take note though that two arcs are similar if and only if they have the same measure, and all congruent arcs may be similar, but not all similar arcs are congruent.